Welcome to this exploration of the paper that expanded blockchain beyond currency. In 2013, a 19-year-old programmer named Vitalik Buterin published a white paper proposing Ethereum, a blockchain that could run arbitrary programs, not just track money. While Bitcoin proved you could have decentralized currency, Buterin asked, what if you could have decentralized everything? Ethereum introduced smart contracts to the mainstream, enabling applications that run exactly as programmed without any possibility of downtime, censorship, or third-party interference. Let's understand how one teenager's vision created a platform for the decentralized future. To appreciate Ethereum, we need to understand what Bitcoin couldn't do. Bitcoin's scripting language is intentionally limited. You can send coins from one address to another with some basic conditions, but that's essentially it. Satoshi Nakamoto designed it this way for security. A simpler system has fewer vulnerabilities, but developers saw potential for more. What if contracts could automatically execute when conditions were met? What if you could build entire applications on a blockchain? What if digital assets could represent more than just currency? Bitcoin's script couldn't support these visions. It lacked loops, couldn't store complex state, and had no way to interact with external data. The concept of smart contracts predates Ethereum. Computer scientist Nick Szabo proposed them in 1994, self-executing agreements where the terms are written in code rather than legal language. A vending machine is a primitive smart contract. Insert money, make a selection, receive the product. No negotiation, no trust required, no third party to enforce the deal. Buterin wanted to bring this concept to blockchain at scale. Instead of purpose-built protocols for each application, he proposed a general-purpose platform where anyone could deploy any smart contract logic. Vitalik Buterin was born in Russia in 1994 and moved to Canada as a child. He discovered Bitcoin in 2011 at age 17 and co-founded Bitcoin Magazine. As he explored the ecosystem, he grew frustrated with the narrow focus on currency. He proposed modifications to Bitcoin's protocol to enable more functionality, but his ideas were rejected as too ambitious. So he designed his own blockchain from scratch. The Ethereum white paper was published in late 2013. A crowd sale in 2014 raised over $18 million, at the time one of the largest crowdfunding events ever. Ethereum launched in July 2015. Ethereum's fundamental advance was making blockchain Turing-complete, capable of computing anything that can be computed. Bitcoin's script can check conditions and signatures but cannot loop or maintain complex state. Ethereum's EVM can execute arbitrary programs, store data, and call other programs. This seems like a small technical distinction, but the implications are enormous. A Turing-complete blockchain can simulate any computer program, enabling applications limited only by the imagination of developers. Ethereum uses an account-based model rather than Bitcoin's transaction-based model. Two types of accounts: externally owned accounts, controlled by private keys like Bitcoin addresses. These are what users have. Contract accounts, controlled by code. These hold both Ether and executable programs. Every account has a balance, a nonce. Contract accounts also have code and storage. This model makes it natural to think about contracts as persistent entities with their own state, rather than just one-time scripts. At Ethereum's heart is the EVM, a global decentralized computer. When you deploy a smart contract, its code is stored on the blockchain. When someone calls that contract, every node in the network executes the code and updates the state. The EVM is deterministic. Given the same input, every node produces the same output. Isolated, contracts cannot access the operating system or network. Universal. The same code runs identically on Windows, Linux, anywhere. Think of it as a single computer shared by the entire world, where no one can shut it down or tamper with the results. There's a catch with Turing-completeness, the halting problem. How do you know if a program will finish running or loop forever? On a blockchain, an infinite loop would be catastrophic. Every node must execute every transaction. One bad contract could freeze the entire network. Ethereum's solution is gas. Every operation costs a certain amount of gas. Users pay for gas with Ether. Transactions include a gas limit. If a transaction runs out of gas, it stops and reverts. Gas creates economic limits on computation. Infinite loops become infinitely expensive. They simply run out of gas. When you send a transaction, you specify a gas limit. You specify a gas price? Miners prioritize transactions with higher gas prices. You're charged gas used x gas price. Unused gas is refunded. Simple transfers cost about 21,000 gas. Complex contract interactions might cost millions. Gas prices fluctuate with network demand. What can you actually do with smart contracts? The white paper describes several categories. Token systems. Create your own digital assets. This became ERC-20 tokens, the standard that powers thousands of cryptocurrencies and the entire ICO phenomenon. Financial derivatives. Contracts that pay out based on external data. If the price of gold exceeds $2,000, pay Alice, otherwise pay Bob. Identity and reputation. Store verifiable credentials on-chain. Prove you graduated from a university without revealing which one. Decentralized file storage. Pay for storage across a distributed network with cryptographic proofs that your data is being maintained. Perhaps the most ambitious application, organizations without management. A DAO is an organization whose rules are encoded in smart contracts. Members vote on proposals. Treasury is controlled by code. Decisions execute automatically. No CEO, no board of directors, no office, just rules and stakeholders. The white paper envisioned DAOs replacing traditional corporate structures for certain applications, investment funds, charities, cooperatives, anywhere rules can be precisely specified. Ethereum conceptualizes the blockchain as a state machine. Current state, the complete status of all accounts, balances, and contract storage. Transaction, a signed instruction to change the state. Next state, the result of applying the transaction to the current state. Every block contains transactions that transition from one state to the next. The entire history of Ethereum is a deterministic sequence of state transitions. This is more powerful than Bitcoin's transaction model. Bitcoin asks, who owns which coins? Ethereum asks, what is the current state of the entire system? Ethereum uses a specialized data structure, the Merkle-Patricia trie, to store state efficiently. This allows quick verification, prove any piece of state with a small proof, efficient updates, change one value without recomputing everything, light clients, verify transactions without downloading the entire blockchain. The state trie stores all account information. The storage trie stores each contract's internal data. The transaction and receipt tries record what happened in each block. Both are decentralized and use proof of work. But their design philosophies differ fundamentally. Since launch, Ethereum has enabled decentralized finance, lending, borrowing, trading without banks, NFTs, non-fungible tokens representing unique digital assets, art, collectibles, gaming items, stablecoins, cryptocurrencies pegged to fiat currencies like USDC and DAI. DAOs, organizations managing billions in assets through code. Layer 2 solutions, scaling solutions that process transactions off-chain while inheriting Ethereum security. The white paper honestly addresses Ethereum's limitations. Scalability, every node processes every transaction. This limits throughput severely compared to centralized systems. Privacy, all transactions are public. Complex patterns can de-anonymize users. Storage costs, blockchain state grows forever. Old data can never be deleted. Oracle problem, smart contracts can't access external data directly. They need trusted data feeds, which reintroduces centralization. These challenges remain active areas of research and development years later. Ethereum has evolved significantly since the white paper, 2016. The DAO hack, $60 million stolen due to a contract bug. Ethereum controversially hard forked to reverse the theft. 2017 ICO boom. Thousands of projects raised funds through Ethereum token sales. 2020 DeFi summer. Decentralized finance exploded in usage and value. 2022 the merge. Ethereum transitioned from proof of work to proof of stake, reducing energy consumption by about 99%. Ongoing, Layer 2, scaling, sharding, and continued protocol improvements. Ethereum's influence extends beyond its own platform. Standardization, ERC20, ERC721, and other standards became industry norms. Ecosystem, the largest smart contract developer community by far. Competition inspired dozens of Ethereum killers trying to improve on its design. Legitimacy proved that blockchain could do more than digital gold. Whether you're bullish or skeptical on crypto, Ethereum expanded the conversation from digital money to decentralized computing. Vitalik Buterin's Ethereum white paper asked a bold question. What if blockchain could run any program, not just currency transfers? The answer created a platform that hosts billions of dollars in financial applications, powers a new digital art economy, and enables organizations to operate without traditional management structures. Ethereum isn't perfect. Scalability challenges persist. Gas fees can be prohibitive. Smart contract bugs have cost users millions. But the core vision, a world computer that no one controls but everyone can use, remains compelling. When Bitcoin showed that money could be decentralized, many saw curiosity. When Ethereum showed that computation could be decentralized, developers saw a platform. And they built an entire ecosystem on a teenager's white paper.